Okay, this is the solution to question number 1 for the practice paper for the Engineering and Mathematics 2014 exam. In this particular question, if we look at it, we're asked to differentiate the function for part A. And remember, the differential tells you the rate of change of the original function. And then we're asked to find the value of x when the differential is 0. So in other words, in a roundabout way, if this was the function, we're asked to find a maximum or a minimum value, because that's the point at which the gradient, the rate of change, equals 0. And then so once we've got that value for x, we can plug that back into the original function here to find out what y is, and that's part C. So I'll run through the solution now, but with all these solutions, if you get to a point where you think you can carry on, pause it and see if you can complete the question yourself. So, part A, let's differentiate this. Y equals 12x cubed minus 3.6x. So the notation I'm going to use for this, which is suggested really, I'm differentiating y with respect to x, so the differential is going to equal, now bring the 3 down and times that by the 12 to get 36, and then I take 1 off the power, so x cubed becomes x squared, and the next one, in differentiating 3.6x, the x disappears, leaving just 3.6. So that's the differential, and that's the answer to part A. Part B asks me to take this differential and find the value of x when the differential is 0. So in other words, I'm trying to solve the equation 3x squared minus 3.6 equals 0. So I've just got to solve this equation. Add 3.6 to both sides. Divide by 36. And then 3.6 over 36 gives me 0.1. So x is the square root of 0.1, which is plus or minus, remember, 0.316 to 3 significant figures. So that's part B done. Part C asks me to put the value of x back in to the original function. We've actually got 2 values for x to put back in, so we're going to get 2 values for y. So, part C, go back to the original function, which was y equals 12x cubed minus 3.6x, and substitute in my values for x. In other words, I let x equal 0.316 in here and in here, and calculate the value for y. And then I let x equal minus 0.316 and work out the value for y. And if you do that, you should get the following solutions. We get x equals 0.316 gives us y equals minus 0.759, and for x equals negative 0.316 we get y equals 0.759. 2 solutions, in other words, one of which is going to be a maximum, one a minimum. And if we think about the original function, it's a cubic function, so you might have expected that if I plot it, I'm going to get a shape a little bit like this, which we get. This is here I've plotted the original function in autograph, and you can see that there are 2 points at which the gradient drops to 0. One when x equals negative 0.3 something or other, which we found, and x equal to positive. So in other words, this sort of confirms our solutions